Hi everyone, we are Group 4 and my name is Puan. Our group members have Diokesin, Wongkaisin, and Kosheni. Today we are going to present our topic, Chapter 3, the Relational Database Model and Entity Relationship Modeling. What is characteristic of a relational table? The characteristics of a relational table are as follows. A table is perceived as a two-dimensional structure composed of rows and columns. Each table row represents a single entity occurrence within the entity set. Each table column represents an attribute, and each column has a distinct name. Each intersection of a row and columns represents a single data value. All values in a column must conform to the same data format. Each column has a specific range of values known as the attribute domain. The order of the rows and columns is immaterial to the database management system. Each table must have an attribute or combination of attributes that uniquely identify each row. Now we go to the next part. There are many types of keys in database management system, such as super key, candidate key, primary key, foreign key, secondary key, composite key, and surrogate key. Firstly, super key is an attribute or combination of attributes that uniquely identify each row in the table. Secondly, candidate key is a minimal super key. It also is a super key that doesn't contain a subset of attribute that is itself a super key. Thirdly, primary key is a candidate key selected to uniquely identify all other attribute values in any given row. It cannot contain non-entries. Fourthly, foreign key is an attribute or combination of attribute in one table whose value must either match the primary key in another table or be none. Fifthly, secondary key is an attribute or combination of attributes used strictly for data retrieval purposes. Sixthly, a composite key is a combination of more than one attribute that can be used to uniquely identify each record. Seventhly, surrogate key is an artificial key that is used to uniquely identify the record in the table. It is just simple sequential numbers and is only used to be edged as primary keys. That's all. Next part, I will pass to Diokesin. Thank you.
My name is Diokesin. Today I want to talk about the topic is database dependencies. Even though database dependencies are common, they are known to confuse students and database professionals. Fortunately, they are not as complicated as they seem, just need to get used to working with them. About database dependencies, why they are important and the different dependencies try to be aware of. A database dependency is a contract that defines the relationship between attributes. It happens when information stored in the same database table uniquely determines other information stored in the same table. It is important to understand what database dependencies are, provide the basis building block for database normalization. Normalization is the process of effectively organizing data in a database. There are two main objectives with a database normalization. The first is to eliminate redundant data, and the second is to ensure data dependencies make sense. By doing this, it can reduce the amount of space a database consumes and make sure that the data is stored logically. Let's have some of the different types of database dependencies. The first is functional dependence. This is a value of one or more other attributes It determines the values of other attributes as more or 1. The secondary is determinant. It is an attribute whose values determines another one. The next is dependent. It's also an attribute in value determinants, but different that the value determined by the other one attribute. The last is full functional dependence. It is initial collection of attributes in the determinant is necessary for the relationship. The next part is integrity rules are imperative to a good database design. Most database management systems have these rules automatically, but it is safer to just make sure that the rules are already applied in the design. There are two types of integrity mentioned in integrity rule is entity and reference. Integrity rules are needed to informs the database management system about Christian contracts in the real world. General integrity rules apply to all databases. Two general rules will be discussed to deal with primary key and foreign key. Entity integrity exists when each primary key within a table has a value that is unique. This ensures that each rule is uniquely identified by the primary key. One requirement for entity integrity is that a primary key cannot have a null value. The purpose of this integrity is to have each row have a unique identity, and foreign key values can properly reference primary key values. Business rules are contrasts of definitions created by some aspect of a business. They can apply to almost all aspects of a business and are meant to describe the operation of example of a business rule may be not ready check is to be performed on return customer. That's all for me. Next, I will pass my mic to my partner, Wong Kai Sing. Thank you.
Hi, my name is Wong Kai Sing. Today, I'm going to talking about entity relationship diagram, ERD. An entity relationship diagram shows the relationship among entity sets. An entity set is a group of similar entities, and these entities can have attributes. About the components of an ERD, they have three components, which is entity, attributes, and relationship. About the entity, they have two types. First is entity. Second is weak entity. About the attributes, there has four types of attributes. First is key attributes. Second is composite attributes. Third is multi-valued attributes. And fourth is derived attributes. In the relationship, there has three relationships. First is one-to-one relationship. Second is one-to-many relationship. And third is many-to-many relationship. Now we are looking to the entity. Entity is an object or component of data such as a consumer, student, car, or product. An entity is represented as rectangle in the ERD. About the weak entity is an entity that cannot be uniquely identified by its own attributes and released on the relationship between another entity. Hence, the weak entity is represented by a double rectangle. Next, we are going to looking for attributes. An attribute describes the property of an entity. An attribute is represented as oval in an ER diagram, like here. Just only oval shape only. Next, we are looking for key attributes. A key attribute can uniquely identify an entity from an entity set. Next, composite attribute is an attribute that is a combination of other attributes. Third is multi-valued attributes that can hold multiple values. It is represented with a double overs in an ERD, like this one. Fourth is derived attributes. That is a derived attribute is one whose value is dynamic and derived from another attribute. It is represented by dash over in an ERD, like dash over shape. In the relationship is represented by diamond shape in ERD. It shows the relationship among entities. Now, we are looking for one-to-one relationship. One-to-one relationship is when a single instance of an entity is associated with a single instance of another entity. Example: a person has only one passport and a passport is given to one person. Now we're looking at the chain notation and crowfoot notation. Chain notation have a diamond shape relationship. And at the crowfoot did not have diamond shape relationship. The relationship is right on the line. Next is one-to-many relationship. It is a single instances of an entity is associated with more than one instances of another entity. For example, a customer can place many orders, but orders cannot be placed by many customers. Now we are looking for how to do. Looking at the chain notation is customer place order. Customer is the nouns, order is the nouns, and place is verb. So looking at here is customer can place many orders. So orders and customer is nouns. Entity always put at the nouns and relationship is the verb at here place. About the drawing for crowfoot, there's a little bit different. This is one and this is many. So one-to-one relationship is one-to-one. At the one-to-many relationship is one-to-many. Also at the chain notation, it is one-to-many. So this mean many. Besides, looking at the many-to-many relationship, there is more than one instances of an entity is associated with more than one instances of another entity. For example, a student can be assigned to many projects and a project can be assigned to many students. Now we are looking first, where is the nouns? Student and project. This is the nouns and verb is assign. That means assign is the relationship. So student assign project and many student and many projects. So it's many student assign many project. So this is many to many. About the participation constraints is have two participation. First is optional participation. That is, one entity occurrence does not require a corresponding entity occurrence in a particular relationship, and is also called partial participation. The second one is mandatory participation. That is, one entity occurrence require a corresponding entity occurrence in a particular relationship. It is also called total participation. That's all for my presenting. Thank you, and I will pass the mic to Cautioning.
In Cautioning, I will explain the several business rules and its powerful ERD of one company. Let me see through these slides business rules. The first one is each employee works in one department. each department works by many employees. This shows the relationship of employee and department is one-to-many. The second business rule is each department works on many projects. Each project works by many employees. This shows the relationship of employee and project is many-to-many. The third business rule is each department has many projects. Each project belongs to one department. This shows the relationship of department and project is one-to-many. This slide shows the crown-foot ERD of those business rules. Let me see the first table. The first table is employee and its primary key is employee ID. The second table is department and its primary key is department ID. Its foreign key is employee name. From the business rules, we know that the relationship of department and employees is one-to-many. So we can see from here, many employees work in one department. For the third table, its entity is project and its foreign key is department project and employee project. We also know that the relationship of employee and project is many-to-many. For this relationship, we can split things into two one-to-many relationship by creating a new table employee project and put the employee ID and project ID as its CK. From the business rules, we also know that the relationship of department and project is one-to-many. So we can see from here, one department has many projects, but each project is belong to one department. That's all for this sample business rules and sample ERD, and this is the end of our topic. Thank you.